Hi, everyone. I'm Ian. I lead developer relations at Worldcoin, and I'm here to tell you about World ID, our Proof of Personhood protocol. So, in this workshop, I will go over what World ID is, why Worldcoin created it, what you can do with World ID, and, most importantly, how to integrate World ID. So, World ID exists to solve one major problem. How do you know who or what is a real and unique person? We're trying to prove that an account actually belongs to a real human, not a bot, and that that real human only gets one account, right? So World ID has been in public availability since the end of July, but we are still in beta. World ID is built to be private, inclusive, and robust. So on the private aspect, we collect very, very little information about you, as little as we can. We never ask for your name, for your email, for your government ID. The phone number that we ask for in the app is optional. So we don't actually know which human you are. World ID is built to be inclusive. We want it to be available to as many people as possible. And we want it to be robust, ensuring that you actually can only get one World ID if you're one real human. So there's a lot of different ways that we look to do this sort of proof of personhood and proof of uniqueness. We looked at email or phone, but neither of those work really well. It's super easy to have a ton of different email accounts or a ton of different phone numbers. We looked at doing official like government ID, KYC, but the issue with that is that it's not nearly inclusive enough for us. Less than half of the global population has a digitally verifiable government ID. We looked at doing web of trust systems, but those don't scale to all of humanity, because in a web of trust system, every hop away from that initial trusted set of like 100 or 1,000 people actually means that you're less trusted. So with that, we settled on biometrics. And within biometrics, there's a lot of different ways that you can prove uniqueness. We looked at using fingerprints, face scans, palm scans, but all of those actually don't have enough entropy to scale to all of humanity. Face ID or Touch ID on your phone can distinguish about 1 in 30 million people, which is fine when you're trying to do a one-to-one comparison, right? When you want to know that the person in front of the device right now is the same as the person who was in front of the device when they set it up. And, you know, the odds that me being based in the US, if the person who steals my phone is one of like 12 people in the whole country who would be able to unlock it with Face ID, I'm pretty happy about those odds. I'll take that. But when you're trying to prove that you're different from every other human, if you only have 1 in 30 million uniqueness and 7 billion people, you're going to have a lot of collisions. So the complete other end of the spectrum in terms of the amount of entropy is DNA, right? Everyone's is fully unique, but that tells us a lot about who you are. And we don't want to know who you are. We just want to know you're unique. It's also really expensive, really invasive, so that one was not a good fit for this either. And what we settled on was iris biometrics. The iris is incredibly unique. There's a ton of entropy there. And additionally, a good thing about iris biometrics is that it inherently involves consent, right? With like fingerprints or face scans, you can get fingerprints off of someone's glass that they drank out of at a restaurant. You can get face scans out of someone walking past a sensor on the street. But with the iris, to get that information, you have to have like a very high resolution photo. So it's not something that someone can like capture passively while you're walking down the street. And if someone tries to get you to scan your iris and you don't want to, you can close your eyes, right? So it's one that works really well for what we're doing. And then how do we get that information from the iris? We looked at just using phone cameras, but the issue there is that the resolution on your phone camera isn't really high enough. And if you try to hold it really up close to your face to get the most out of that resolution that you could, they're usually not designed to focus that close. And the ones that are, the cameras with like macro lenses on phones, that's not most phones, right? So that would break the inclusivity aspect. We looked at off-the-shelf hardware, but again, it's a semi-trusted environment and is usually built more as like a kiosk setup, like if you're familiar with Clear at American airports for getting through security. So it's not super portable, makes it hard to get it to a ton of people all around the world. So we had to settle on custom hardware. And that custom hardware is the orb. You might have seen this at events in the past. It's at our booth here. We also have a clear one at our booth if you want to take a peek inside, but also 95% of the hardware is open source. So the orb has been in development since early 2020. It's gone through plenty of revisions since then to make it more secure, faster, generally all the things you try to improve with hardware. And what the orb does is that it checks to make sure you're a real human, not a cat or a dog, not a photo of a human. Also make sure that you're alive. It takes photos of your irises and computes an iris code, a non-reversible digital representation of the pattern of your iris. And it checks to make sure that that iris code is unique from the iris codes of everyone else who signed up at the orb. And once that's done, it verifies your world ID by adding the public key of that identity to a Merkle tree on chain. That's essentially the list of identities. So World ID has been designed to be privacy first, decentralized, and open source. As I said earlier, we don't really collect any information about who you are, right? You don't have to give us any personal information. In terms of decentralization, that's one of our highest priorities right now. So the protocol is in the domain of the Worldcoin Foundation. All of the code is also open source. So everything that's on chain, all of our developer tools, our developer portal, you can view all of that on Worldcoin's GitHub. And there's a lot of different use cases where World ID is valuable, right? Anti-bot and anti-Sybil are two really, really big, really broad problems. So voting is one great example. You want to make sure that someone is actually a real person when they're voting and that they only get to vote once. On social media, you want to know that an account isn't a bot. For customer incentives, this is one that I think is really cool. I've spun up probably a dozen different emails to claim like Netflix free trials back when they still did those. But if they had used World ID, I wouldn't be able to get more than one free trial, right? So because they know that I would only be able to get one, maybe that 2-week free trial would be a 3-month free trial instead. Because after 2 weeks, maybe you've gotten through like half a season of a show, and then you're like, oh, well, I don't have the free trial anymore. But if you spend 3 months with Netflix, you're really going to be stuck in there after that 3 months. That's going to be your like go-to weekend thing to do. We've also designed World ID to be super, super easy to integrate. You can use it on the web, on mobile, and on chain. And there's two main ways to integrate World ID. One is sign in with Worldcoin, and the other is anonymous actions. So I'll start going through sign in with Worldcoin. This is the simpler integration, but it's not as flexible. So let's see how sign in with Worldcoin works. So here I have our developer portal pulled up. I can go log in. So you can either log in with an email address or you can click sign in with Worldcoin. So when I click sign in with Worldcoin, it shows me this QR code here. So I scan that QR code from within World app. You can also scan directly with your phone's camera and it will deep link you into the app. Yes, this is a live demo. The internet here isn't too great. It's thinking, it's working on it. It doesn't normally take this long, and we're also about to release a better bridge to handle these connections between an application and World app. That makes it way faster. All right, let me refresh this page and try that again. There we go. So I tap verify with World ID. And then redirects me back to my app and I'm logged in. So I'll also show you a little bit of the developer portal right now. I have an app in here because I've built quite a few things. But you can click the app list here and add new app. So when you create an app, you can choose if you want it to be in staging or production. Staging, we'll use our simulator rather than World app. It has a bunch of pre-verified identities that you can use for testing if you're doing things on-chain, and I'll explain a little bit more about this later. If you're doing things on-chain, staging is for testnet, production is for mainnets. And then you can choose on-chain or cloud. For sign in with Worldcoin, you have to choose cloud. It won't work for on-chain apps. So you can give your app a name and optionally a description, and I can explain a little bit more about the developer portal in a bit. But that's what sign in with Worldcoin looks like. It's super easy for the user. And there's a handful of ways that you can integrate sign in with Worldcoin. So you can use our integration with Auth0, a major authentication engine. For example, Auth0 is used when you sign into OpenAI's ChatGPT. You can use Next.js, which is an open source authentication library for Next.js. You can use some other authentication engine with our OpenID Connect well-known file that makes configuration super easy. You can custom implement OpenID Connect flows, but I'll walk through how you would do it with Next.js. This is all you have to do to integrate WorldID sign-in with NextAuth. So this is in NextAuth's configuration page. And you can have a list of multiple different providers. That can be sign in with Apple, sign in with Google, sign in with Facebook, sign in with WorldCoin. You have to put in the ID of WorldCoin, give it the name, tell it that it's using OAuth, which OpenID Connect is built on top of. You pass it the URL of our well-known file, which tells NextAuth a lot of the configuration details about WorldCoin sign-in provider. You give it this client ID and client secret that you'll get from our developer portal. So I'll actually go ahead and create one right now so you can see where to find those. So once you've created a cloud app, you can go to sign in. Your client ID is the same as your app ID, and then the client secret, you can reset that, copy it, but don't share that with anybody. And then you'll have to set a redirect URI, depending on what authentication engine you're using. That will vary a little bit, but it just tells our sign-in provider where to direct your user after they've finished the sign-in process. So you have to give the client ID and client secret, and then you have to map some information returned from our sign-in provider to NextAuth's internal representation of your user. So the ID would be the unique identifier. That's the user sub from the profile in OIDC terms. And then we also map the credential type, which tells you if your user was verified at the orb or if they verified their phone number in WorldApp. Those are both the supported credentials within WorldApp, but the phone verification is a much weaker proof of personhood and proof of uniqueness, right? Because getting multiple phone numbers is fairly easy, but it's a way for people to use sign in with WorldCoin if they can't get verified at the orb. So now I'll walk a little bit through anonymous actions. These are a lot more flexible, but they're a little bit more complex. And these you can use either in a more Web 2 fashion with our API or on-chain. So with anonymous actions, you're getting to know that a user is a unique human doing an action that you specify once. It's typically once. You can actually have that be as many times as you'd like. That could be, I want someone to have 3 accounts on this social media platform that they can mark as verified. And then there's a specific signal that you can include in that proof as well that is just a piece of data that can't be manipulated between when the proof is generated and when it's verified. So the flow for anonymous actions is that a user scans the QR code from IDKit, our front-end widget. On the user's device, a zero-knowledge proof is generated, and then your application receives that proof and verifies it, again, either with our API or on-chain, depending on your use case. And that proof you get is right here. So this proof has a Merkle root, so the root of the Merkle tree that the user has generated a proof against, and that Merkle tree is on-chain. That's that list of verified identities. And that Merkle root we have, and we check against Merkle roots on chain to make sure that it's actually a true Merkle tree of the verified identities and not a Merkle root that somebody invented. This nullifier hash is the unique identifier of that user in the context of your action. So if I perform an action twice with the same world ID, it will generate the same nullifier hash, which is how we can tell if someone's performed an action before or if they haven't. For sign-in, that nullifier hash is actually that unique identifier of that user sub in OIDC terms. But if I perform a different action or sign into a different application, I get a different nullifier hash, which prevents knowing that those 2 actions were performed by the same person. You'll see that the public key of your identity isn't included anywhere in here. Not even Worldcoin can tell which actions you're performing with your World ID. This proof is a lot longer than it actually shows here. That is just the actual zero-knowledge proof itself. And then the credential type will either be phone or orb. And that's just informing the application of if you're orb verified or if you have simply just verified your phone number in the app. So now I'll show you what using IDKit looks like, and I'll also show you our simulator. So this is just a little demo page we have. Oh, I need to refresh this. So we'll select staging for this. Let's just say the action is Istanbul. We'll accept orb credentials. So this continue with Worldcoin button, this would be just like the button you would have in your application that would say verify with World ID or something similar. So it shows this QR code. And in the simulator, if I'm running the simulator on my mobile phone, I can use the camera to scan the QR code just like I did in the production app. But for testing, a lot of the times it's easier to run it on your computer here. I can actually just click the QR code to copy the link contained within it, paste it in here, and then I can go ahead and verify. So with the simulator, every identity here is both phone and orb verified, and you can select at the time of verification which ones you want to test with. So let's just treat this like a user that's verified with both. I click verify with World ID, and we see that it was a successful verification. So IDKit, if you want to integrate it into your application, it's easiest to do as a React component, but you can also do so in vanilla JavaScript. In this example, I'm walking through TypeScript. So we have this one component, IDKit widget, and there's a handful of parameters that I have to pass to it. One is the name of the action, and you can configure that in the developer portal. The app ID here, you also get from our developer portal. And it will be either app underscore some long hexadecimal string, or if it's staging app, it'll be app staging some long hexadecimal string. The onSuccess and handle verify parameters are both callback functions that you define. Handle verify is called immediately after the proof is received from the user. And if you throw an error in that function, it will display within the IDKit modal to the user. And then onSuccess is called after after the verification is complete. So if you have both defined, if handle verify throws an error, onSuccess doesn't get called, but handle verify is optional. And for on-chain use cases, you typically wouldn't use that because in order to verify that proof, the user has to send a transaction on-chain. Finally, you can set which credential types you want to accept. So that can be an array of these credential type type objects if you're using TypeScript, or if you're using vanilla JavaScript, it can just be the string orb and the string phone. And then it has this child component that is the button that tells the widget to open. So it's pretty simple. This one component is really all you need in your front end other than those two callback functions, right? And this IDKit response, this proof returned from the user, is the input to those callback functions. But we've received this proof. We do still have to verify that proof. Just receiving this proof doesn't really mean anything. Everything so far has been in your application's front end. The user could always just generate a proof that matches that format but isn't actually meaningful data and pass that to your application. And if you don't check that the proof actually verifies, then you don't actually know that that user's a real unique human. So this is what it would look like to verify that proof in your application's backend with our API. So this is the off-chain use case. So at developer.worldcoin.org as the base URL /API v1 verify, and then your Worldcoin app ID, that's our verify endpoint. So you send a post request with a JSON body that'll contain everything that was in that response from IDKit. Additionally, you'll need the action and the signal if one was included. I did forget to talk about the signal. That's also a parameter that you can put into IDKit here. That signal could be like a user's wallet address if they're claiming an airdrop gated by World ID, just because you know that between when this proof is generated and when you verify the proof, if that signal is different between those two steps, the proof won't verify. So you can make sure that this piece of information doesn't get tampered with. So you'll include the signal if you had that, the action, everything returned from ID kit. And then if the proof verifies, our API responds with a 200 status code. And this is where in your backend you should perform whatever action you want to let the user do. So that could be marking them as verified in your database or whatever else. Otherwise, you should throw an error. If you are doing API verification, I'd recommend doing this verification in the handle verify callback function. But you'll need to pass the proof from IDKit to your app's backend, and then your backend will have to call our API to verify that proof. If you want to do on-chain verification, you'll have to write your smart contract, and in the function that does whatever your user wants to do that's gated behind World ID, let's just say that's minting some tokens, you'll need to call our smart contracts. So if you only have one action that you want the user to perform, it's most gas efficient if you set the address of the World ID smart contract, the app ID, and the action ID all in the constructor at deployment time. You can also set these as like parameters in the smart contract function. And then we calculate this external nullifier based on the app ID and action. World ID as a protocol is built on top of Semaphore, and that external nullifier is what acts as the action. So we compute the external nullifier by combining the app ID and action ID and hashing them in this specific way. We do have template repositories for all of the examples I'm going through here that implement this properly. So you can just reuse this to calculate the external nullifier. And then in this function here, you would take in the signal, the root of the Merkle tree, the nullifier hash, and that proof that you receive from IDKit. So the first thing we do is check to make sure we haven't seen this nullifier hash before, so that we can limit the user to doing this only once. For API verification, our API handles tracking that. And in the developer portal, you can set exactly how many times you want to let someone do a specific action. But for on-chain use cases, you have to track those nullifier hashes yourself. So if this nullifier hash is in the list of nullifier hashes that we've seen before, let's go ahead and revert. We don't want to let the user do this action. After we've made sure that they haven't done this action before, we call the verify proof function on the World ID smart contract with the root of the Merkle tree, the group ID, which will be 0 for orb credentials. Phone credentials are not supported on chain. So that group ID you can hard code as 1, or hard code as 0, or set it in your constructor. We have to hash the signal in a specific way if we use one. Otherwise, that signal should just be an empty string. And then we have the nullifier hash from that proof, the external nullifier, that is that combination of your app ID and action, and then the proof. If that proof verifies, the function will simply continue. If that proof doesn't verify, this will revert. So finally, after we've verified that proof, we should add this nullifier hash to the list of nullifier hashes we've seen before to prevent the user from doing this again. And then you can go ahead and do whatever it is you want your user to be able to do. So that's when you would mint those tokens to them or let them claim that NFT, whatever that may be for your use case. So we have $20,000 worth of prizes in this hackathon, $5K to the best overall, $2,500 each to the best governance app, the most creative use case, the best AI use case, and the best sign-in with Worldcoin app. We have 2 honorable mentions of $1,000 each, and then a $3,000 prize pool. And that's it. So if you guys want reference to any of this information that I went over here, you can go to worldcoin.org/Istanbul23. That also includes links to all of our template repositories and things like that. And you can also find me at Worldcoin's booth. I'll be here basically all weekend. If I wasn't here for work, I would be here hacking. So staying here until 2, 3 a.m. is not uncommon for me. And I know that it can be a little unintuitive sometimes. So please come ask me for help if there's anything you're confused about, any issues you're having. And yeah, thank you guys.